How do I write chlorine? The element chlorine. All right, so that's a diatomic element. What's another one? What? F2, another one? Another one? And what about the gens? So if you just remembered, if you just remember your diatomic elements, you would have gotten those right, wouldn't you? Some of you didn't know how to write the formula for aluminum oxide. That's disappointing. Yeah, I'm going to say it. That's disappointing. All right. Okay. That's what the test looks like, okay? That's what the test looks like. The only other thing that it's not really new, but I'm going to do some demonstrations here. And you're going to practice translating Chemonese into English, English into Chemonese. And I like the demonstrations anyway. They're kind of neat. I'll also have some questions on these, and I even have some bonus questions on here. So most of the tests, though, I've already talked about what was on the test. All right, here's what I did yesterday. Yesterday, I said, okay, when you put two chemicals together, how do you know something's going to happen? Sometimes it doesn't. Gold plus water yields what? Gold plus water. It doesn't react. But what happens when I put this and this? Does something happen then? How do you know? How do you know a chemical reaction took place? Well, I look for things. Maybe a color change occurred. Maybe heat was given off. Maybe I said, hey, I didn't have a solid. All of a sudden a solid appears. What about a gas? You produce gas. Anyway, that might tell me that chemical reaction is taking place. So chemists wondered, what is it that actually drives the reaction? What actually makes a reaction want to go and react? And so they're called driving forces. And so we saw one yesterday, and I want somebody to read this to me in English. So take a chance and just read this to me in English. And this is how you're going to get better. All right? Volunteer and do it and said, I don't care. If I make a mistake, I'm going to be better. All right, I need a volunteer. I got to hurry. Who wants to read this to me in English? Freddie, go ahead.
Hydrochloric acid
Yes.
plus sodium, OH.
So you're going to study your polyatomic ions tonight.
Yes.
Sodium hydroxide.
Yes. Yields to water plus sodium chloride.
Yes. Everybody get that? Now, this looks like water. This looks like water. And if I put them together, it'll look like water. How did I know chemical reaction took place? Well, I had to have a little buddy. Who's my little buddy that came along? What was his name? What's this called? You guys are either tired today or really tired yesterday. What was this stuff called? It's right there. Phenolphthalein. Phenolphthalein. Okay?
I forgot that one.
All right. Now, what happens if I put phenolphthalein in an acid? It's clear to begin with. What happens if I put it in an acid?
Clear.
It's clear. What if I put it in a base? What's a base? That's a metal hydroxide, isn't it? Group 1, group 2 metal hydroxide. It's going to turn pink, isn't it? So I put it in the base and it turned pink. I added some acid to it, and the pink color disappeared. That means that the acid was reacting with the base and neutralizing it, wasn't it? And that's why it disappeared. Okay. Now, the next thing I did, now don't pay attention to this one because you haven't seen this one before yet. I think I did this one yesterday, didn't I? All right. I think so. I know I did. I'll remind you about it. Somebody read this to me in English. Somebody read this to me in English. Somebody else. Take a chance. Zoe, you don't volunteer enough. Here you go. All right, go ahead.
Silver nitrate plus calcium chloride yields silver chloride plus calcium nitrate.
Excellent. Excellent. Everybody see that? Now, if you remember, this looked like water, and this looked like water. But when I put them together, this white solid appeared. Remember that? And the driving force was not the production of water, like over here, it was the production of water. When water is one of the products, that tends to make the reaction take place. And then, what's this one? Not water, but a solid. Remember that solid? And I'll do another one today with solid. Let's do another one. There you go. All right, ready? Let's get, I need somebody to read this to me. Read this to me in English, okay? Who wants to try that? Who else doesn't volunteer very much? Reese. Yeah.
Number 5.
Yeah, read that to me in English.
Lead nitrate.
Oh, not always metal. Which lead nitrate?
Lead 2 nitrate.
Yes.
Plus sodium iodide.
Yes.
Yields lead 2 iodide.
Yes.
Plus sodium nitrate.
Yes. Yes. Very good. All right, let's try it. All right, so here, what does lead 2 nitrate look like? What does lead 2 nitrate look like?
Looks like clear.
Looks like water. What does sodium iodide aqueous look like?
Clear.
Okay.
Not when you mix them though.
All right, let's try it. Are you ready? I'll get a white. Let's do a white background on this one. Ready? Ready? Watch it. Watch it now. Whoa!
Whoa!
All right. Now,
It was blue yesterday.
no, it was kind of a whitish gray. It's kind of white. Anyway, what is in there? If I let this sit for a while, if I shake it, you'll see there's little bits of solid. There's a yellow solid in there, okay? So the formation of a solid was the driving force. Now, next chapter, I'll actually show you, next chapter, how to look these two things up, and one of them, you'll find out which one the solid is. But for this chapter, you don't have to know which one the solid was. All right, let's go with this guy here. The next one I'm going to do, and I'm going to do the rest of the demonstrations with the lights off. So if you can help me out, turn both sets of lights off. And I'll have a white background and a dark background. So, wait a minute. Oh, that was dark. Whoop. All right, what I have here, and I'll show it to you on the camera. I'm going to get it ready here. It's been sitting in the storeroom for about 5 years. So,
Wait, Miss Fanny, what are we supposed to be like writing down?
okay, go down to number 5. Yeah, wait, not 5. What is it? Yeah, 5. No, 6. Let's go number 6. 6. Okay. All right, well, let me show you. This is called magnesium ribbon. Matter of fact, what I have here, I have a whole bunch of it. I have a whole bunch of it right here. And it's called magnesium ribbon. What do you think magnesium ribbon is made out of?
Magnesium.
That's right. What do you think aluminum foil is made of? Just aluminum. What do you think zinc dust is made of? Zinc. And what do you think gold bullion is made of? And the second word is simply telling you what shape it's in. If it's like a ribbon, then it's magnesium ribbon. At home, I have aluminum foil. If you grind up zinc and makes it look like a powder, it's called zinc dust or zinc powder. And bullion's a big block. And so the word aluminum foil, it's aluminum. It's just aluminum. And this is just magnesium. Now, what I'm going to do here, if you look at your paper, it says, I'm going to react magnesium with oxygen. Everybody see that? All right, so here we go. Ready? Is there oxygen in the air?
Absolutely.
All right, ready? Go.
Fire.
Go.
Go!
Okay, so in chemistry, at this temperature, magnesium doesn't want to react with oxygen. But sometimes you have to give them a kick in the butt. And so what you're going to do is, if I can get these guys to move faster, then they might want to bounce into oxygen and react. So what I'm going to do,
Shove it up.
all right, so what I'm going to do is heat it up a little bit until these guys get a little hotter. Now, what's going to happen is when it gets hot enough, it's going to react with oxygen. Whoa. It's going to react with oxygen, and unfortunately, I don't want you to look directly at it. It's incredibly bright.
Well, if
Wait, if I'm wrong, do I
Um,
have to take exams?
I'll get a Braille copy for you.
Oh, no.
No, that's all right. Here we go. Ready? Magnesium.
I'm going blind.
Magnesium plus oxygen, and here we go.
Holy cow.
Look at the can. Look up there.
I'm looking
That's
at
such
it.
a late one.
Matter of fact, they use magnesium when they make flares. If you have a really bright flare, you can use magnesium.
Let's do it
All right.
again.
I have some more.
I'll call y'all.
Now, take a look, and let's see what it looks like here. Now, this is some of the magnesium ribbon that didn't react, and I didn't scrape that off. It's got a lot of coating on it. But do you see this little gray powder? Okay, now, what do you think that gray powder is? Look at this paper. Magnesium plus oxygen, and it's a synthesis reaction.
Magnesium oxide.
Yes, magnesium oxide. Now, how do you write the formula for magnesium oxide?
MgO2.
Mg what?
No, 2MgO2.
Well, no, I'll balance it later. How do you write magnesium oxide?
MgO.
Okay. Now, once you have the formulas, now you balance it, and it comes out to be like you see up there.
Shouldn't there be a 2?
You okay on that? Yes.
Shouldn't it be 2Mg and then O2?
Okay, now, why would I write O2? Because magnesium is plus 2, and oxygen is minus 2.
I thought oxygen died.
Wait a minute. Okay, can everybody listen, please? This is a very teachable moment. Oxygen by itself is diatomic, but it's not by itself. You can have as many oxygens as you want in a compound with something else, can't you? So I don't need to write O2 there because it's not oxygen. It's magnesium oxide.
Well,
Now maybe that's what confused you. If I have, why did I write O2 here? I said magnesium plus oxygen. Why did I write O2 there? Because it's just oxygen, isn't it? It's just oxygen. Okay. Anyway, now what I'm going to do here is kind of unusual. I'm going to take the product of this reaction and make it a reactant of the next reaction. So what I'm going to do here is take magnesium oxide, and I'm going to add some water to it.
I was doing 7 now.
Okay, now, I will tell you that it's not that exciting, but you might even ask yourself, I don't believe you. I don't believe that something happened. And so what I'm going to do is, I'm going to kind of convince you that something happened. And here's my little buddy again. I'm going to put some phenolphthalein on there, and let's see what happens.
Is that red?
Purple.
Now, when does phenolphthalein change to pink?
When in contact with acid.
Not acid.
Base.
A base is a group 1, group 2 metal hydroxide, right? Metal hydroxide. So, I would not expect a first-year chemistry student to know what the products are. But let's take a look. I do know that I took magnesium oxide and I added water to it. But the phenolphthalein tells me I probably made what?
A base.
And what base would that be? Magnesium
Oxide.
hydroxide. Now hydroxide is -1, magnesium is +2. That's why I needed 2 hydroxides here, didn't I? And then that happens to be balanced already. Remember tomorrow, if it's balanced already, you have to write balance. Yes.
Socrates, how do you know that you need magnesium hydroxide?
Okay, I can't be absolutely certain, but I do know when does phenolphthalein change pink? When you have a base. Now, what base could possibly be made here then? What base could possibly have been made here?
We're gonna get
What base could have been made here? Wait, let's take too long, okay? What base could have been made here?
magnesium.
Magnesium hydroxide. See, sodium hydroxide, lithium hydroxide, potassium hydroxide, calcium hydroxide, all of those are bases.
Is it the ones that end with I?
No, hydroxide. It's the hydroxide that makes it a base. Yes.
What, is it just hydroxide?
Is what now?
Is hydroxide the only thing that's a base?
For first year chemistry, yes.
Okay.
If you take advanced chemistry, we'll talk about some other things. But first year chemistry student, if you see a group 1 metal or a group 2 metal and it's a hydroxide and you put it in water, it's going to be a base. Okay. Well, anyway, good question. Now, let's do another one. Let's flip this over to this side. Now, what I'm going to do now is actually very dangerous. And most of you will never see this the rest of your life unless you can look on YouTube. I have even hours worth of YouTube on this kind of stuff. But most people have never seen these in reality, right in person. So I have here a metal, and this metal, if you look on the periodic table, about 2/3 of the elements on the periodic table are metals. But the pattern of the periodic table says if you're a metal, the further left I go, the more reactive you are. So I have some sodium here. It's going to be pretty reactive. And so I'm going to go ahead and open that up, and we'll get some sodium out. Now this thing not only came in this box, packed with a lot of stuff around it, it came in a metal tin that was closed, and it also came into another container, and then even the container is stored in oil.
Yeah, it's like one of those.
It's stored in oil and won't react with oil, but you would never store it in water. So let me show you what this looks like. Now I do need you to kind of be quiet so I can finish these. I want to make sure I finish all my demonstrations today. This is something you'll probably never see in reality the rest of your life. Now I'm going to take one of these out here. There we go. And this is a piece of sodium. I'll go ahead and put it in here. And let me get a black background. Now sodium looks kind of dull right now, but I do want to show you a property of it, that all of these really alkali metals, you would think a metal would be very, very hard, but this thing, I could take a butter knife and cut it. Now, as soon as I cut it, it gets very shiny. But after a while, the shininess goes away. It's so reactive, it'll react with oxygen in the air and make sodium oxide, and it'll make a dull color. If I cut it again and make a fresh cut, you'll see a shiny surface again. So I can get it. Now, what I'm going to do in my experiment, I don't want to use a huge piece. That's pretty big. Okay.
I think you should use that.
Okay, I'll use, that's as big as I'm going to go there. I don't want to do any more than that. Now, I'm going to protect this, get this out of the way.
We don't want any explosions.
You know, they're going to be, it's going to be a mini explosion. How about that?
Yeah.
Oh.
All right, here we go. Now, what I'm going to do is I'm going to put this, put some water in here.
Where'd it go?
It's down by sound.
Okay, now, ready?
No.
Sodium, you will never find sodium in the earth because it's always combined with something else. It's so reactive. So let's watch it react with water. You think I might have to heat this up?
Yeah.
I don't think so. This is going to be a spontaneous reaction. Here we go. Uh-oh, sticking.
Can't see.
Right.
Pick him up there. Oh, it's sticky. It's the fuse.
Now, by the way,
Blow up.
this metal, it's making like a sizzling noise.
It's gonna blow up.
This metal is should be sinking down to the bottom of the water,
Watch it.
but it's not because it's traveling. I'm gonna see if I can get it to travel a little bit.
Make that
Get away from the edge.
Oh, it stinks.
Get away from the edge. Okay. Wait a minute.
We'll do another one.
Okay, wait a minute.
Oh my, think I heard about it.
Now, what's happening is that, if everybody be quiet, okay? Quiet. It's ripping water apart. And the gases that produce, mainly hydrogen gas, is riding on a cushion of air as it goes across there. And that's why you see it go dance around like this. Now, what's interesting is, how do you know that, how do I know, is there something else that might have been formed? I happen to know that hydrogen gas is formed, but is there something else that might be formed?
Base.
Oh.
So what is possibly one of the products?
Sodium hydroxide.
Yes. Now you're really thinking like a chemistry student.
Science.
Science.
Now, let's see if we can write this, okay? Let's see if we can write this down.
Where'd you get that base from?
We made it.
You just made it.
Off of what?
Uh,
Oh my god.
okay, good question. Wait, no, wait, no, good question. Wait. Good question. Sodium rips water apart, makes H's and OH's. The sodium then combines with OH. How do I know that? The phenolphthalein says you have NaOH in there. Now that little gas that was produced making a sizzling noise, you didn't see it on this one, you'll see it on the next one, is actually hydrogen gas. Now how do I know that it's hydrogen gas? I can't really tell on this one as well, but on the next one you'll see it, and I'll show you how that works. I'll tell you how I know it's hydrogen gas. So what I'm going to do on this one is I'm going to put this guy back. This is sodium. And one thing about the periodic table, which is a pattern, is as you go left, the metals get more reactive. But as you go down, they also get more reactive. So I have an element here that's below sodium on the periodic table. What's it called?
Potassium.
Okay, now this one is dangerous. Okay?
Oh.
And I'm not going to ask the school for rubidium because it would probably shatter this bowl.
Probably looks like.
Okay, so now what I'm going to do is, this is already reactive enough, but I'm going to show it to you.
Can we get uranium in here?
It's radioactive, so the answer is no. All right. All right, here we go. Now, if you'll take a look, this is potassium, which looks very much like sodium, but I want to show you again, the same properties occur if I cut it. I can cut it with something almost like a butter knife and make a really shiny surface here. But this one will dull even faster because it's even faster at reacting with oxygen in the air. Now, this one I do have to be a little more careful about because it is more reactive. So I'm going to put the bigger piece back. I'm not going to put that one.
Go big or go home. We could do
What if
both.
you did the whole thing, the whole
Go
can,
big, we could do go.
Wait a minute. Let me see about this.
whole container?
No, I had to be careful. All right, here we go.
What if you-
That's enough. That's plenty. I have 3 little pieces, okay? All right, now, this one is so violent that when it rips water apart, the energy that was holding water together is enough to ignite the hydrogen gas. Hydrogen will ignite. So here we go. I'm hoping to see a flame here. Uh-oh, wait a minute.
No.
You meant no water, not.
I didn't have any water.
Oh.
That's why you screamed no.
No, water.
No.
Should we get that thing to pull up there?
I'm gonna do.
Oh.
Here's the second piece. Piece number 2.
Fireworks.
Fireworks.
Oh.
Fire.
Remember that video? You guys like on that video. Remember that Sir Humphrey Davies? Whoa, okay.
Big one.
Oh.
Fire alarm.
Oh. I gotta do it. I'm sorry.
Okay, now, wait a minute. Even though the gas that's produced did ignite, so chances are it's probably hydrogen gas, it was.
Base.
And now, was anything else produced?
Oh, it's a base.
But, all right, so let's see if we can write this out. Ready?
Oh yeah.
let's see if we can write this whole thing out. All right, let's do it. What's the, here we go. What is potassium plus water? Potassium plus water yields. And how do I know potassium hydroxide was probably made?
Because you can see with the saline.
Phenolphthalein, change pink. And then how do I know that hydrogen gas was made?
Because you can see it.
Well, how do you see it?
Because in my eyes, like.
What's a property of hydrogen gas?
Smoke.
Flammability.
Flammability. Flammability. Now, so here's my thing. There you go. And then now we can just balance it. How do you know that KOH was produced, a product of the phenolphthalein gave me an indication you had a base there? What evidence do you have that the gas was hydrogen? It was flammable, wasn't it? Now, I could have, and I'm running out of time, but even the sodium one, it made a lot of gas, but it wasn't enough heat to ignite the gas. But I think if I lit it, I've actually never done that in class. I do have to be a little careful about experiments like that. So I'll tell you what I'm willing to do. What if I get the sodium back out?
Yes. We'll do it together.
If I get the sodium back out, and this time
Let's do everything.
I'll try to light any gas that might come off. How about that?
Mr. Feeney?
Yeah, that's a good idea.
It's just because it reacted like a baby.
All right, here's some sodium. That's too big. Woo! Okay, that's all right. They used to sell this. They used to have regular people could buy this, and then after 9/11, they said, "Are we stupid or something?" And what happened is, because people were buying this. This is a true story. Somebody bought a big 5-pound block of sodium in oil. They took their boat out on the lake, and they thought, "Watch everybody!" They threw it overboard, and everybody, "Yay, yay!" And then the fire caught the boat. It actually somewhat spattered and caught the boat on fire, and it sank. Wait. All right, so here we go. You ready? All right, everybody ready? The sodium in water